All right, so in the last video, we talked about the multiplication property of square roots. So now we're going to talk about the division property of square roots. Remember that fractions is a way of showing division. And so just like, and this is going to make me, there we go. Just like when we were working with exponents and we could square both top and bottom, it's the same thing with the radicals. When we square root a fraction, we're going to square root the top and then square root the bottom. So, for example, the square root of 36 over 49, I'm going to treat it as the square root of 36 over the square root of 49. Now, if they're not perfect squares, go ahead and see if you can simplify them first, because sometimes you can simplify them into perfect squares, but sometimes it's also easier to simplify them before you start simplifying them later. So from here, the square root of 36 is 6, and the square root of 49 is 7. And that is our answer. Technically, it's plus or minus, but I don't think it's looking for the two answers. It's just, can you simplify? When I simplify, it's going to come down to 6 over 7. And that's what we're looking for. So that's the division property. Square root of a fraction, we find the square root of the top over the square root of the bottom. So what is the simplified form of this one? Now, this would be one of those, let's simplify before we even take it out of the square root. So 2 goes into both 8 and 50, so I'm going to divide by 2 on both top and bottom, but also there's an x on top and bottom, so I'm actually going to divide by a 2x. And so then I'm going to end up with 4x squared over 25. No x because we divided by x. Then that becomes the square root of 4x squared over the square root of 25, which gives us 2x over 5. And that's our final answer for that one. So again, I simplified it first because 2 went into both top and bottom. Also an x could divide into both top and bottom, so we divided those out first. That left us with perfect squares, 4 and 25, and x squared. Made it the square root of the top over the square root of the bottom, and then simplified our answer to our 2x over 5. All right, so now what happens if we don't have perfect squares, especially on the bottom? Because if you remember on like the second or third slide, we talked about the 3 things that we need in order to be considered a simplified fraction. And one of those is that there are no radicals in the denominator. So when I look at A, nothing goes into 3 and 7, and 7 can't be simplified. So the way that we rationalize a denominator is really to multiply by that simplified radical. So if I multiply by the square root of 7, and what I do to the denominator I have to do to the numerator, then the square root of 7 times the square root of 7 is just going to give us 7, because we're squaring that bottom. And then I'm going to take the square root of 3 times the square root of 7, which gives us the square root of 21. Now, the 21 on top is under a square root. I cannot simplify the 21 with the 7 on the bottom because the 7 on the bottom is outside of the square root, whereas the 21 is inside. They cannot divide out because they are not, in a way, they're not like terms. They're not in the same position in order to divide out. So that is our final answer, the square root of 21 over 7. I also know that 21 is a simplified radical because nothing goes in. There's no perfect square in 21. We've got 3 and 7. No perfect squares. All right, so now looking at B. When I look at 8, I can simplify the 8. So instead of multiplying by both top and bottom by the square root of 8n, I'm going to simplify this 8 first. And so I know that 8 is 2 and 4, and that 4 is 2 and 2. And really, if you want to get things like 8 comes up a lot. For some reason, I don't know why, but it is one of the easiest ones to remember. 8 is, if you look at it, we're taking a 2 out and we are left with a 2. So the square root of 8 is 2 radical 2. 2 square root 2. And so what we have here when I simplify that 8 is I will have the square root of 7 over 2 square root 2n, because the n is still part of it. Now, when I go to rationalize this, I'm not going to multiply by the 2 on the outside. I just want to get rid of this square root of 2n. So I'm going to multiply by the square root of 2n. And again, what I do to the denominator, I have to do to the numerator. And so what I end up with is on top, 7 times 2 is 14. So we have the square root of 14n over, we had our 2 on the outside, and then 2n, or square root of 2n times square root of 2n is 2n. And so then as we simplify the bottom, we end up with the square root of 14n over 4n. And that's our final answer. So again, if you can simplify your radical first, then you end up making it easier to simplify your fraction in the end. If we would have just multiplied by the square root of 8n, then we would have been doing some simplifying of our radical on both top and bottom. So that kind of saved us a step by simplifying our radical first. And that's how we rationalize denominators. We really just multiply both top and bottom by the radical that is in the denominator itself. So if you have any questions, reach out. I will see you in class.